All right, so what'd you get for the number one? 9i, right? That's an easy one. What about number two? Grant, louder. Correct. Negative 3i radical 2. All right, the negative is for this. That's 9 times 2, right? For the 18. So for the 9, we bring out the 3. That's there. Since it was negative 18, we brought out the I, and then the 2's left, right? What's the conjugate of number 3? Yeah, just 6 plus I radical 3, right? It's in the right order. Is this one in the right order? No. So when we put it in the right order, the real part in front, and the imaginary part in back, what's the conjugate? It's radical 2 minus 4i, right? Okay? Now, how do I multiply two binomials? What do we call it? FOIL it, right. So first is 2 times 3. Outside is 2 times negative radical 2, which is negative 2 radical 2. Inside is radical 2 times 3, which is 3 radical 2. And then last is negative radical 2 times, radical 2 times a negative radical 2, which is a negative radical 4. Okay, but what is the square root of 4? 2. So that's 6 minus 2, 4. Negative 2 radical 2 plus 3 radical 2 is a positive 1 radical 2. Those are like terms. Make sense to you? That's something you should be able to do, right? Then this one would be 6 times 1. 6 times radical 3 for outside. Inside, radical 3. 3 radical 3 times 1 is 2 radical 3. And then 3 radical 3 times is like 3 with a 3, and then radical 9. What's the square root of 9? 3 times that 3 would be 9. So 6 plus 9 is 15, and 6 plus 3 is 9. Okay? Should be able to handle those, because we're going to do some of this today. Except instead of the radicals, they're going to be 6 plus 3i and 1 plus 3i, or something like that. We're going to do that. Okay, that's where we're headed today. All right, let's go over the homework first, which was page 361, right? And Scott, we only had to do even. We didn't have to do them all. Oh, that's all right. You got extra practice, right? All right, we started at number 18, right? 18 of 34, even. All right, 18 is way down here. I gotta find it. Three and 1/3 or 0.3 repeating. That one came out nice. 20 is negative 1 and 4. That one came out nice. You had a perfect square under your radical sign. 22 is 2 plus or minus the square root of 113 all over 4. 24 is negative 1 plus or minus I times the square root of 3 all over 2. 26 is plus or minus 2i. 28 is 1 plus or minus the square root of 21 over 2. Number 30, you had to find b squared minus 4ac, and you get a negative answer. So you get 2 non-real solutions. For 32, you get 0 when you do the b squared minus 4ac, so you get 1 real solution. And then 34, you get a negative again, so you get 2 non-real solution. So what I had to do is the b squared minus 4ac part for 30, 32, and 34. Questions on any of them? It's pretty easy assignment, wasn't it? Quadratic formula, simple. All right, and then it's called the discriminant, that b squared minus 4ac, remember? All right, some of you weren't quite sure what it looked like on your homework. All right, no questions though? We're okay? All right, so today, like I said, we are going to work with some complex numbers. We're going to add, subtract, and multiply with complex numbers. And we'll see if we might be able to get to division, I don't know. So we did our warm up. All right, adding, subtracting complex numbers is similar to adding, subtracting variable expressions with like terms. Simply combine the real parts and combine the imaginary parts. So just treat that I like a variable, okay? Like you would an X or a Y. All right, you can't add an X and a Y together, right? So you can't add an I with anything else but another I. Okay, the set of complex numbers has all properties of the set of real numbers. So you can use the commutative, you can change the order and still get the same answer. Associative, we can change the grouping and still get the same answer, and distributive properties for complex numbers. All right, so just combine like terms. So what's this first one? Say that again, Ryan.
-2.
Yeah. You just go 4 plus a -6 is -2, and 2i plus a -7i is -5i. That easy. Grace, what's the next one?
Is it -2?
Well, it's minus a -2, so what would we do?
You add it?
Yeah, so that would be what? Good. And then you got minus a -3.
What is this? Negative?
Well, what's minus a -3?
-1?
No. Well, yeah, no. Just do this part. What's minus a -3? I. Plus 3i. So think of -2i plus 3i. Yeah, 1i, right? Or just I. Okay? That makes sense to you guys? Trent? How about this one? Yes. The negative makes that 3. Yeah. And it also makes the 5. Right, so what's 2i minus 5? Yeah. Some people would do this. Can we do that? No. Could we do it if that minus sign wasn't there? Yeah. Since that minus sign's there, we can't think about distributing it. Okay? We're just, this is like distribute. You can distribute the negative if you want to think about it that way. We good on those? That's pretty easy, aren't they? Combining like terms, adding, subtracting, complex numbers. All right, you can multiply complex numbers by using the distributive property and treating the imaginary parts as like terms. Simplify by using the fact. Remember, that's kind of small, but remember, x or I squared equals -1, right? So we got to remember that. We're going to get some I squareds pop up. Okay? When that happens, Kate, like if I get a 5i squared, that's like 5 times -1, so it becomes -5. That make sense? All right, so distribute. Go ahead, Kate. Whoa.
-4i plus 2i squared.
Good. So there's there's that I squared. So what happens to that 8? Comes -8. Here's what I do when I see that. I just cross this out and change the sign. So now we're supposed to put it in this form, right? Real part in front, imaginary part in back. So my answer should look like what? Okay,
-8 minus 4i.
yes. That's how it should look. Real part's -8, imaginary part's -4i. We good so far? All right. Now I got 2 binomials. So what am I going to do here? We're going to FOIL, right? All right, Danny, go ahead.
It'd be 12, 4, fraction of 12 minus 3i, and then plus 24i minus 50.
Good. Any questions on how we got there? So when I squared popped up, what happens? Turns into +6, yeah. So again, I like to do this. Just change that sign. Does that make sense? Because we're thinking it's -6 times -1, right? So it becomes +6. So Danny, what's my answer then?
21i plus 21i plus 8.
Yeah, but let's put the 18 where? In the front. So we have it in the proper order. Real part in the front, imaginary part in the back. So like a mullet, right? Yeah. So like Ryan's hair, kind of. Questions on that? Sammy, you all right? All right. Go ahead and do the left one, far left one, on your own. I'll see how you do. Come and check it. Better in or you still kind of struggling? Okay, you don't have to put that part in better.
No, is it?
Like this is.
Yeah, sounds good. It's either seven or I think it's gonna stop there. Way down. That guy's my favorite.
Oh, yeah, that's a good person. All right. Beverly, what'd you get?
I got 37.
Close.
85.
Yeah, you gotta add.
I was.
Okay, so what do we call these two? 2 plus 9i and 2 minus 9i?
Complex conjugate.
The conjugates, right? You guys see that?
Yeah, conjugate.
So, all right, these are complex conjugates. What happened to those two middle ones? They canceled. What's going to happen every time you multiply complex conjugates? They're going to cancel the middle ones. Okay? So first, for outside negative 18i, inside positive 18i, and they're going to go away, right? Every time that's going to happen when you're multiplying complex conjugates. And then last is negative 81, 9 times 9, I times I is I squared. So what happens to the negative 81 becomes positive. So it's 4 plus 81, which is 35. Whenever you multiply complex conjugates, all you got to do is square that and add them. Square 2, square 9, and always addition. It will always be addition. That's like the shortcut. You realize they're conjugates. You can just square the first term, the second term, drop the I, don't worry about that. And always addition. Okay? This one's easy. What is it? Well, it's negative 30i squared, but what is it then? 30, right? Okay, what about this one? 6i. Negative 10i squared, so it's plus 10, so I should flip it though, right? So it's in the correct order. You guys with me on those three? Making sense?
Yeah.
All right. Let's go ahead and do this one and then we'll stop. We'll show division tomorrow. All right. So the measuring unit can be raised to higher powers as shown below. Okay? I always show I to the 0 too. What's anything to the 0 power? 1. Okay? So, what? Look at the pattern. I to the 0 is 1. I to the first, anything to the first is itself, right? I. Pay attention to this. Okay? I squared we know is -1. I cubed is like I squared times I, which is -1 times I, which is -I. Okay? I to the fourth is like I squared times I squared, which is -1 times -1, which is +1. I to the fifth, I to the fourth we just figured was 1 times I, so we get I. I to the sixth is like I to the fourth times I squared. I to the fourth we found out was 1. I squared we know is -1, so it's -1. And then 4 and cubed, we got the cube was -I, the fourth was 1 times thing. So watch what happens. You get a 1, an I, a -1, a -I. A 1, I, -1, -I. 1, I, -1, -I. Those are the only things that 4 answers that show up. Every time, no matter how high you go for an exponent. When you raise I to a power, it's either 1, I, -1, or -I. It goes in that order. You guys see that? There's only 4 possible answers. Okay? 4 possible values. Again, I always start with the 1. I always put that in front. Okay? And then here's how you do a problem like this. You want to keep going that pattern until you get to the 42nd one? No, you don't want to do that, do you? Since there's only 4 possible answers, I divide 42, that big exponent, by 4. Okay, why am I dividing by 4? Because there's only 4 possible answers. All right. So how do I do long division? Well, I'll show you then. You go take this 4 and say, can I divide this 4 into that 4?
Yes.
Yes. How many times does it go in? 1 time. You put the 1 up there. Then you go 1 times 4, which is 4, and you put it underneath this 4. You make a little bar and do what? Subtract. Right? What do you get here? 0, right? So since it's a 0, I can just not put anything. But if this was a 3, 2, or a 1, then I'd put whatever it equals. Right? What do I do with this 2? Bring it down, right? So how many times does 4 go into 2? Well, 0 times, right? Remember, we're saying 4 doesn't go into 2. It's too big, right?
Yeah.
So that's 0 times. What's 0 times 4? 0. 2 minus 0 is 2. That's my remainder, right? 10 remainder 2, right? Or 10 and a half, right? Or 10.5 if you added a 0, right? If you did that. So, all I'm worried about is that number. Whatever the remainder is, this and these are equivalent. What do we know I squared equals? -1, so that's my answer. Okay? 63, same thing. 63 divided by 4. Does 4 go into 6? How many times? Once. What's 1 times 4? Subtract. Bring down the 4. How many times does 4 go into 24? 6 times. What's 6 times 4? 24. What's my remainder? 0. So I to the 63rd is like I to the 0. What's anything to the 0 power?
Shouldn't that be 63?
Oh, yeah. Why did I do 64?
Yeah, the perfect square looks pretty.
Yeah, I don't know why. I have no idea why I did that.
Just leave it alone.
Sorry about that. How many times does 4 go into 23?
5.
5 times. 5 times 4 is 20. What's my remainder? 3. So this isn't I to the 0, it's I to the third power,
Oh. Okay.
which is negative I. Remember, it's 1 I, negative 1, negative I. All right? So here's what you got to learn. Which you don't really need to learn these because you already knew these 3, right? You already knew anything to the 0 power was 1. You already knew anything to the first power is itself. And we've learned already that I squared is negative 1, right? Right.
Can we just, like, if it's double digits, can we just look at the last digit of the exponent and tell people what it is?
No,
No.
that just worked out those two that way. That's a good observation. But okay, so that's the pattern. Now I know a lot of you don't like long division. Okay? So if you use your calculator, all right. What was it? 42 was the first one. Divided by 4, you got 10.5, right? Whenever the remainder is 2, that's like 2/4. What's 2/4 reduced to? A half, which is 0.5, right? So, I guess I'll put it on this time. Let's do this first. That move over. So this would be, a whole number. The 64 was going to be a whole number, right? It was 16, no remainder. If it was a remainder of 2, it's 0.5 because it's 2/4. If it's a remainder of 1, it's 1/4, which is what decimal? You should know this. If it's a remainder of 3, it's 3/4, which is what decimal? 0.75. Okay? All right, so if I do this one, there's a 7. I'll use my calculator. 7 divided by 4 is 1.75. So since it's 0.75, what's my exponent? 3. So this is like 1/2 times I cubed, which is like 1/2 times negative I, which is negative 1/2 I. Do that one. You're right so far. So what's that times that equal? It is, but you know what that equals? Yeah, you do. Where'd you write it up here?
Hey, now my next question is going to.
Come on, the P. Finish it yet? Yeah, you're right. I'm finished. What's that equal? You got it. No. No. That is to that, right? No. That's that number, right? You already got that up there, right? So we'll come on by the yeah, right? Does that make sense? No. What's that? No, you put that times that. Strong. You don't multiply it. That just tells you it's that, yeah. What's the answer? 6. When you divide 14 by 4, your calculator says 3.5, doesn't it? So the 0.5 means what? I squared. So this is like negative 6 I squared, but remember I squared is negative 1, so it's 6. Or what we did earlier, we did this, didn't we? When you see the I squared, didn't we already do that? Okay? So, we didn't get to division, so this is changing, this assignment. All right, let me change it. We're just going to 60, lost my spot, 62. Okay. 386, 46 to 62 even. Tomorrow we'll do the division part of complex numbers. All right. Any questions? Good job today. Pretty easy stuff, right? Okay, that last part can get tricky, but if you just learn that little table there, no remainder, the answer is 1. 1 remainder or 0.25, the answer is some I. Remainder 2 or 0.5, negative 1. Remainder 3 or 0.75, negative I. Okay? Get it? Got it? Good? Look good, feel good? You are good.